Today's standard is 8.EE.1, know and apply the properties of integer exponents. And our essential statement is I can use the product of a power and quotient of a power property for exponents. So quick review before we get into that. What are exponents? If you have a number 4, okay, that's right here, to the power of 3, the big number is called the base. The little number is called the exponent. The exponent means how many times you multiply the base. So in this case, if you have 4 to the power of 3, it would be 4 times 4 times 4. Here's another example. If you have 3 to the power of 7, the exponent means how many times you multiply your base, which is 3. So you're going to be multiplying 3 7 times. Today, all we are doing is simplifying exponential expressions. I do not want you to multiply these numbers out. And also, another thing, a common mistake is that when people see 3 to the power of 7, they think that means 3 times 7, which equals 21. That is not the case. The exponent means how many times you multiply the base. Okay, so moving on. This is the rule for product of a power. This is a property. If you have any base a to the power of m and you multiply it by any base a to the power of n, remember these two bases obviously have to be the same, they equal a to the power of m plus n. In other words, in our own words, what does this mean? If you have two exponents with the same base and you're multiplying them, really, to simplify those exponents, you just take that base and you add the two exponents. Okay, so let's do an example. All right, so here's our first example. Let me cover up the side right here. Okay, here's our first example. We have 7 to the power of 2 times 7 to the power of 4. This is our problem. Then we're going to do our work and show our work, and then we're going to have our simplified answer. So 7 to the power of 2 really means 7 times 7. 7 to the power of 4 really means 7 times 7 times 7 times 7, okay, 4 times. So when we write it all out, we count how many 7s we're actually multiplying, and we have 6 7s. So really we have 7 to the power of 6. Or in other words, 2 plus 4 equals 6. And you can only do this when you have the same base. Then you can use the product of a power property. So let's go ahead and do another example. Okay, so here we have 900 to the power of 3 times 900. Okay, keep in mind, this is another thing you need to know. Whenever you do not see an exponent on a number, the exponent there is always 1. Okay, therefore 900 to the power of 3 times 900 to the power of 1 is just 3 plus 1, so it's 900 to the power of 4. And I'm going to go ahead and open that up. This is something that you need to know. That's why I have a star next to it. When there is no seen exponent, the exponent is 1. All right. Next, quotient of a power. Okay. On the left, again, double starred. You have to have the same bases in order to do any of these exponential expressions, okay? The bases must be the same. If your bases are not the same, there is nothing you can do to simplify your exponential expression. Okay, the next rule we have is quotient of a power. And the rule is if you have any base a to the power of m over a to the power of n, that equals a to the power of m minus n. Remember, okay, this line right here means division, really. That's why we're doing the quotient, okay? This means division, the slash. A to the power of m over a to the power of n is equal to a to the power of m minus n. So we'll do an example. Here's our first example, okay? 5 to the power of 5 over 5 to the power of 2. So how do we write it out the long way? 5 to the power of 5 really is 5 fives. And 5 to the power of 2 really is 2 fives. Anything over itself equals 1. So that's why you see this big giant 1 over 5, because those cancel out, because anything over itself equals 1. And then we don't have anything else to cancel out, so all we have left is 3 fives, and you write it 5 to the power of 3. And that's our simplified answer. If you have trouble, write out your exponents and then cancel out what you can. The next example, we'll use the rule. And again, over here, start. Anything over itself equals 1. Anything. 10 over 10 equals 1. 100 over 100 equals 1. 853 over 853 equals 1. Okay, anything over itself equals 1. All right, next example. 8 to the power of 30 over 8 to the power of 4. If we use our rule, which is right here, okay, what you do with these exponents, when you see this division sign, when you see this, what do? You subtract your exponents. So that really equals 8 to the power of 30 minus 4, which is 8 to the power of 26. No, I don't want you to tell me what 8 to the power of 26 is, because that's a really big number. I just want you to simplify this expression right here. So when you see this, you know you're going to need to subtract. However, for these two examples, the biggest exponent was on the top number in the numerator. So what happens when the bigger exponent is in the denominator? Okay, so here's an example. 9 to the power of 3 over 9 to the power of 4. I'm going to go back and write it out. Excuse me. Write it out like this so that you can see what is actually happening. 9 to the power of 3 is equal to 9 times 9 times 9, 3 times. And 9 to the power of 4 is equal to 9 times 9 times 9 times 9. So I wrote it out. So when in doubt, write it out, okay? So I know that 9 over 9 is 1, so I cancel that out. Again, I know that 9 over 9 is 1, so I cancel that out. And again, I know that 9 over 9 is 1, so I cancel that out. So I was able to cancel out 3 9s. Then I'm like, okay, there's nothing else to cancel, so what do I have left on the top? When you have nothing there, you really have a 1. And on the bottom, I have 1 9. 1 9. So my answer in this case for the bottom one is a fraction, 1 over 9 to the power of 1, or just 1 over 9. Again, if you have any questions, feel free to let me know.